So next exercise that we start to get a little more advanced shapes using simple functions. This is what we're gonna build. It's called the Pythagoras Cup, and that's the way it looks inside, and that's usually how it looks from the outside. So you can see that the shape of the cup itself depends on what we're gonna sketch, but the function remains the same. Yep. See, we can actually, if you want, we could do this kind of we can even go to add this kind of shapes and textures around once we finish to cut it, to build it. Let's start. First, I go to Solidworks, open new, part. I'll start from the front plane. We're gonna first start by using the function revolve, then sweep, sweep cut. But first revolve, front plane, sketch, sketch. I now open the sketch, you see, I can see the dot, I can see the two icons, sketch one of name of part. So the first thing I'm gonna do, I'm gonna place my axis, knowing that I'm using a circular function such as revolve. And now let's start to sketch. Since we're gonna do a real glass, we're gonna have to start to use more sizes. So I'm gonna sketch average shape. You can see that I'm not trying for now to put any sizes. That's gonna come as a second step. Now I want to know, let's go back up a little bit until here, and I close my shape. So the first thing I want to define that my glass will have a total height of 9 centimeters. Let's do something small. We can always enlarge it before we print. I want to tell him that with my dimension that the top is 40. Remember that every size I put here will be doubled. Now let's tell him that the thickness of the feet is 3 millimeters. I'll click on that line, click on the side, 3. Here I want to tell him that this line is 6. As you can see, we can define whatever we want depending on our need. I want that the height between these two lines, that the gap that is between the hollow part inside the cup and the floor will be 3. Actually, it's important to have a little bit of height here. If not, the glass might bounce or behave in a weird way on the table. There is another part I want to tell him, that between this point and this point, you can see that I need to be careful because here I'm going to the side, here I'm going straight down. I want straight down, and this is 25. Okay, if things move like this, you can always grab it, bring it back. Now, if you want that this line will be exactly aligned with this, we can tell him that click on the line, control on the keyboard, click on the dot, and here on the left, you can tell him coincident. And now this line and this point are connected. You can see that now it turned black. Before it was blue, it was free. And control Y, now it's black after I applied the thing. If you want this, we can still define, so this is gonna be part of the free details in the design. If you want it to be thick, if you want it to be this, you can even put it like that, but don't cross. You see what he's doing? If it crosses, you have a shape within a shape. He's telling you this is wrong. That's why it turns from dark to white. If it's white, it means you have something wrong with your sketch. If it's dark gray, it means your sketch is correct. Good. I think that's enough sizes for that area. There is one thing that we can tell him. For example, I want that the angle of the cup will be exactly 45 degrees between this line and this line. So you can see that if I tell him a smart dimension between two lines, he's telling me directly, he understands that if these lines are not parallel, he understands that I want to put an angle, he's helping me doing it. Let's say 45 degrees. Good. If you want this to be not sharp but round, you can replace the line by doing 3-point arc, or you can also do a fillet, and then you see it's already softer. So we can feel that we have a good base for our glass. up. And now we're gonna do the revolve. So I go to sketch, features, revolve, and you can see the glass. If you want to move your glass, do a long push on the wheel of your mouse and move your mouse, and then you can move your object. That's it, you have a cup. Okay, now let's go back. Yeah, let's play with and some function that we didn't use yet. We learned that how to put fillet on a sketch, and here, if you see here, you also have fillet for shapes. So if I click on this and I tell him on that specific line here, I want fillet, you can see that he's giving it to me. I can click here as well, and I can make my shape rounder, softer. That's how you control your design. It doesn't have to be everything to be soft and smooth. Sometimes to have a blend of sharp and smooth can be interesting as well. But this is so you know, fillet, make it round, chamfer, make it sharp. For example, I'm gonna make a chamfer on the edge of the glass. I click on the small arrow to see the additional function, chamfer. I click on the edge and I tell him something small, and now I have sharp edge on my glass. I'm gonna delete that function not to confuse the next part of the exercise. I go back to the left, click on the name, right click on the name of the function, delete. And now I just remove the function. Maybe it's a good time to save, Control S. Or you can click on the floppy disk and you give it a name. Glass. Put it somewhere. Here you can see the files I do with other students for other project. Download, save. Good. But now we have a shape that is full. I want to carve it empty. So I have two options. Either I can go back to the sketch I did and change it, or I can use the revolve cut function. Let's use revolve cut to practice. I come from the same direction that I sketched the original glass. Front plane, sketch. This way I can see the sketch function. Click on sketch. Here open for me a sketch. I can see the red dot, the icons on the side, sketch 2 on the top. I'm doing this on purpose because at the beginning when we start building in 3D, it could be confusing to know I am in a function, am I in a sketch. So these are the visual cues: red dots, 2 icons, sketch 2 of name of file on the top. So now that I have this, I want to sketch the shape. But now that I actually change and started to build, I can use this shape to get the shape and to get the sketch that I want without having to resketch it. I could, but I could also save time. So for example, if I tell him I want to use this block and I want to get like if I cut this block where I sketch, how does that look? It's like when you do a Digun Khofshi and you put tape on a model and you want to get and you start to sketch a line, and the volume, like the body of the mannequin is giving you that shape on the paper. It's exactly the same. So right now we have a font. We are using a font that we are sketching in the middle, on the edge of that cup. So the software is going to give it to us automatically. In order to do that, I do click on solid bodies. There is a little arrow. Click on fillet. That's the name for now of these bodies. We could change it and rename it to something else. If I want to rename this, normally I can rename 3 item. I can call it glass. You see now it's there. So it's usually changed that name to the last function I used, which you can give it a name. So solid bodies, little arrows. I see the list of bodies in my file. Click on glass. And here, if I have convert, that's copy paste that we learn. And at the bottom, I have intersection curve. And you can see that he's giving me the shape. Like if I would be cutting that glass exactly on that plane, I would get that sketch. That's great because that's what I want. So now I'm going to use trim entity to remove parts that I don't need. We know that using revolve, I must sketch only half. And now I want to keep the top part. So I'm going to do continue with trim entities, delete the part that I don't need, select, delete. You can see my sketches here. And now I will click on the one line, go to offset entities, the tool that allow me to offset path, like in Illustrator, to duplicate with a delay. And here I will tell him I want 3 millimeter. And you can see that is reverse. I can choose which side of the line I want to copy. Selecting chain is either taking only the line or the whole sketch. You can see that these tools have been built to help me sketch faster. And I can even tell him, please do base geometry. So the original line will be changed status to the Mekufkav, to the dashed line. And like as we learned, the dashed line is there to help me sketch, but not part of the sketch. And if not, you can always actually delete them. But having them allow me to see how much did I put between them. So in the future, if you want to work clean, that would be the proper method to do. But right now, we could simply, I will do it again. I could simply do that. I click the line, offset is duplicating everything in case of I didn't remember that part of the function, reverse inside is show, and now I just delete, yes, and delete. It's just warning me because there was it's telling me you add a size, a dimension associated to that line. That's why it's telling me, do you want to delete this? Okay. Now, before we continue, I want to control where my cap, where will be the bottom of my cap. So I can click on the line. I want this line to stay there. So I will click on fix the anchor, the organ, so it will not move when I will do the next part. And I will go to continue to sketch using regular lines. I'm gonna close. Here you can even do it that way because we are like cutting through. Here you can see they're helping me being aligned, and I click on it. So I want to be sure that this is horizontal. Here it's telling me it's horizontal, but in case of it's not, click on the line. Here you can see it's empty, horizontal. Now for sure it's horizontal. And I want to tell him that this bottom line is exactly 15 millimeter. I'm adding sizes to make you practice sizes. Could be 10, could be 12, doesn't change nothing, but 15 is a good middle ground. So now I have the shape that I want to cut off out of my block. So I have a closed shape. I can see that my shape is closed because the shaded sketch contour is activated and showing me that that area is closed and ready for the next step. Features, revolve cut that look like a camembert, and spin, approve, and cut. So now we have an hollow cut. Moving on to the next step, I'm going to ask to see my shape from the front by using space on the keyboard. Here I want the front plane. Front plane is always in the middle, and I see it. Okay, let's move to the next step. We need to create the center part that will help us generate the effect that is special to the Pythagoras Cup. I'm actually checking the recording in Hebrew on my other screen while we're building to be sure that everyone on all groups are building to the same sizes. That's why I'm a bit delayed sometimes. Okay, so we want to move off our object to be able to see it from the top. And like we know, I cannot sketch on curved surface, but I can sketch on flat ones. And this one is flat. That's why I made you do it horizontal in the previous step. So I want to sketch on this, and I want to add like a little column, a little bump inside the glass. Sketch, circle, and because we walk directly above the center of my sketch is already the center of the part, so I don't have to look for it. If not, you could see if I get close to the circle, it's showing me where is the center. Escape on the keyboard, smart dimension, click on the edge, another click somewhere else, and we write 20. Approve. Now I want to tell him that that sketch wants to become a box or like a column. So I click on the sketch, extrude, and now I'm adding things. For the Pythagoras Cup to work, this cannot be above. That would never work. It needs to be a little inside. And the height is 30. 30 is a little too much for that specific shape we sketched. So I will tell him 25. Approved. And now we want to round the top in order to make it a little more aesthetic. So there is a few ways to do that. The simplest way is to use fillet. You can find it somewhere here in the middle. You click either on the face, this is called the face or surface, and you can also click on the edge. And here I'm telling him that I want to make this as round as possible. So you can see that if I can either use math or I can use my eyes and decide if I want it to be perfectly spherical or a little less. In that specific context, I advise to make it a little less, so it will have a little, you can see this little circle on the top. So let's put 8. And I have it. Good. Now let's sketch the inside part. And I just want to have the sketch with all the sizes. Let's do that. Okay, so now we need to sketch, we need to cut our glass in two, and we need to see inside the glass to be able to cut where the pipe is supposed to be. So I'm going to ask to see the curve from the side, space on the keyboard, click on the center cube. That's it. Now I'm going to use that function that allow me to see if I cut my section view. It's called section view. If I cut my object in half, how does it look? Approve. So now it's just for display. It didn't really cut it. One plane. I want to make a sketch. Open a sketch, and now we're going to start the slightly technical part where we have to be precise. Let's put a center line. This one I really want a line, so I can have it going exactly here, up. Let's start until there. Now I want to put a circle align this. You see, it's helping me to make it correctly. Up. Now I want to have a line coming from here and going there. Today we're gonna use fillet because it's faster, and you could use 3-point arc. For example, if I want that this point will be exactly aligned, I could do it, but soon, since we're gonna do a fillet, that's gonna change. Actually, he wants things to be aligned. This is software that likes kind of Apple design. It doesn't have to be, so you know. The only one that I'm gonna use as a curve is that one, 3-point line. I want it to go from here. And okay, let's put a line before, from the edge until here, and then from here to here. Click, select the two lines with first line, control, press on the keyboard, second line on the left tangent. Here I'm going to use trimline to remove this. So now we can see that our pipe is going to travel like this. If I want to control exactly how much plastic there is between this and that, I can put a center line and a dimension to tell him I want this to have 5 millimeters between this and that. I want this circle to be need to be careful if it's a radius or diameter. I can see here it's called, you have a little d, so that's a cue that it's 10. But if I put 10, no, it means that it's actually radius. That's interesting. Okay, now I want that between this, the bottom of the glass, and that dot, I want to have 2 millimeters, and I need to be careful that that dot is coming out. If I want this to be exactly straight, you can see it's going up a little bit. It's is popping up. If I want it to be really aligned with this, with the bottom of the glass, I can add a center line. Click center line, put an horizontal line at the end of it, and I can tell him that these two lines are tangent. Now I know that he's gonna enter through it and goes up really smooth. So the liquid is gonna do up and up. Good. Let's add two more fillets. One here, one there. And actually the fillets are a bit too big, so let's put 10. I can change the size on the left, and I tell him exactly where I want it to be, and I can push it up to 15, and we finished. So the liquid is gonna enter from here, go up to the side and down. So this is the way to learn how to do like internal piping through a block, because we can do that in the digital world. And that's it. We finished with that. So now I go to features. I go to it's interesting, it does not give me sweep cut yet, so I will do approve, sketch. I tell him I want to work with my sketch number 4, and yes, I want to use the sweep cut that look exists. So now you understand that the block, the icon is exactly what we are doing. We are cutting the blue pipe inside the gray block. I'm gonna use circular profile, and here let's tell him that it's 3, and now we can see how it behaves. And with the preview, we can even adapt. Let's put 5 or 4, and if we put 4, you can see the bottom of the pipe will be exactly aligned with the bottom of the glass. We could put a little bit more. It's going through and down. Approve. And that's it. We have, if I remove the section view from the outside, I don't know that this glass has been prepped, and will make little surprises for people that put too much in their glass, having a shape and a bottom. And at this point we do save, and if we still want to change the overall design of the base, we can do it, but be careful, because now we're gonna play with the time machine effect. Because if I go back in time to the first function I did, any change I do now will impact the rest. So if I do right click, edit sketch, and I tell him that this base is a little thicker, so for example, first I want to tell him that this and this is not moving, and I want this a bit thicker. That, for example, I will have 5 millimeter here. Approve. Now you can see this, what used to be like this, what used to be thin, if I go back now, actually when I see I did Control Z, I can't go back. It's not allowing me to go back to reapply what I just did. So be careful with Control Z. I edit, and I would just make a smart dimension, telling him that this little line is actually 5, and issue. Approved. So now I have the base, I have the negative space inside, and I finish with this. If we want this glass to be a bit softer on the lips, if we use it, remember that if you do this in 3D printing are not food safe, so you're not supposed to use it. But if it's just one time to see how it behaves, that's one thing, but you're not supposed to actually use this for drinking. So here I'm using the fillet function. It's here in the middle. The fillet is what makes edges softer. I'm telling him that fillet will be 1.5 because I remember that I put the thickness of my plastic being 3. So since a fillet is trying to make a perfect half circle or quarter circle on the edge, it cannot be bigger than the thickness of plastic that I have. So that's why if the total plastic is 3 and I want to have round in and out, 1.5 multiplied by 2, 3. Therefore, I have the shape. And here we start to have a glass that is nice. And we did that in 20 minutes. Not too bad. Okay, so now let's add some special content, because you remember that we saw that, and I like that kind of texture. So let's do something in the spirit of, because I want to keep it short. We could do something like that by taking a bit more time, but we could definitely have dots and shapes applied to it. So what happened if I want to have a texture around, but like we saw, I can't sketch on a curve. I can't sketch on a surface that is not flat. So I need to use a trick. So I'm going to ask to see my shape from front. Excuse me. And I'm going to use extrude cut to make a little curve. Let's make a little shapes like this, because let's say that it's mid and the eyes use usually hexagonal shape. I can use the circle inside, telling him 7. 7 is a good number, and that's it. A good shape. I could with smart dimension, letting him know exactly how it is placed. Let's at 77. Let's play with numbers now. Okay, so but I don't want this. I don't want to cut through it. I just want to carve a little shape, or I could add a little shape on the edge, but I want just to carve a little gap. So I don't have to cut starting from my sketch plane. This is it. That's what's written here. From where do I cut until where do I cut? So here I'm gonna tell him, please don't start from the sketch. Offset. Offset means you start from a place where I tell you to cut. You can see that now I'm starting from outside the shape towards the cut. And here we can play with the settings. One of the settings is called offset from surface. I tell him that's the surface. And here I can tell him, please, you're gonna enter into the plastic 1 millimeter. And you can see it's trying to translate the shape of the cut. Here I need to play with the settings that it's actually enter into the plastic. Here I was outside. You can see there is a bit of white. It's not cutting into it. Reverse offset. All the settings on the left. I'm always playing with that's where we play with the settings. Here is the depth until which I enter. So if I tell him 2 millimeter, you can see it's entering more. 1 is enough. Reverse offset to choose to cut into the block. Translate surface. You can see how it's a bit more perfect or not. So this for now is not a must. Approved. So now I have a little cut inside the edge, slightly inside the plastic, but I want to duplicate it all around the glass. So in order to do this, I can ask to see that sketch, for example, and here I could see the axis. That's one way to do it. Or I could use, soon we're gonna see that we can actually use planes to define axis. That's gonna be for the banana example. So I'm gonna tell him I want to use that axis, and here I have linear pattern. If I click under, I also have circular pattern. In circular pattern, I can use, here he's asking me where is the axis. I can tell him here it is, and he's asking me what kind of either bodies, but I can also tell him which features I want to duplicate. So in order to do that, you can see that now where I usually have my tree, my construction tree with the function I did, it's being covered by something else. But here you can see that I have the name of the file here. If I click on the little arrow, I can get a kind of a copy of a secondary tree here. So I can tell him I want to use that function, and please duplicate, spin it around that axis. It's like same logic like revolve cut, but I'm revolving a function, not just a sketch. Now I'm putting this example at the end because that's a little advanced. Here, how many copies, and I can control how many copies is cutting into the glass. For example, 21. If we start with 7, let's keep with 7, and that's it. So instead of having to do that from 21 times from different angle, I have it here. And I have already a pattern. Now, if I continue my pattern, and under this, I make from the front plane another sketch with another shape, and I'm doing the same. I could even place it slightly under and play with that. Okay, I have a feeling I'm not from the front. That's interesting. Okay, let's say I'm putting one here that has a little more. And I can put this a little lower. And the third. Up and up. I can tell them with center lines by one line between each. I'm telling him that these two lines are equal. I'm just playing with things that we learned. I'm just doing it faster. I could tell him that these three circles are also equal. Circle, circle, circle. If you do, for example, by mistake, you select the surface, just click on it again, pressing Control on the keyboard. Equal. Beautiful. Now I could also make additional pattern here and another one here. I could play with that, telling him that this and this would be equal. Good. And I will do exactly the same function we did before. Extrude cut. With a bit of luck, is remembering what I did. Not this time, so offset. I will tell him I want to do it from outside. Offset from surface. He's asking me which surface. This one. And now he does remember. Reverse offset to be sure that I cut into the block. Approved. Now I have this little pattern here. I'm gonna hide this. Actually, I did it too fast because now I do want the axis, sure. Now I can be a little more efficient, saying I want to use that function, I want to use that axis. I'm gonna selection of the function, Control on the keyboard, click on the axis, and then I click on circular pattern, and now he understood that I want to do it, and approved. Now I already have my glass with additional pattern that look like bubbles, and maybe 1 millimeter. It's look deep, but we remember we just cut 1 millimeter depth inside the block. That's the thickness of a nail. But if I feel that it's too much, right click on the name of the function, edit features, and I can tell him, you know what, it's 0.5. It's not that deep. Approved. And now I have bubbles on the side of my glass. This is ready to print. It's ready to be prepared for print. I will save. And the format, if you want to see your glass in perspective, because you can see that right now on my screen, it's look a little off, that like it's look like the top is fatter than the bottom, that it's kind of, the shape is loose. This is because the display that it's using when I build is not perspective, it's called isometric. If I want to see it as a perspective, I need to play with the function here. If you go to the television, you can choose perspective, and you can see that what it did, it already looked a little better. Only do that when you finished, because if you do that while you sketch, it kind of break the structure of how I can align things from plane to plane, from side to side. But it does help me visualize before I start to do something. Here, if I go to that block, I can choose to see it how it is when it's empty. If you want to do like screenshots for technical things, technical images for presentation, that's really cool. For this one, you can also do it just like black lines, or if you want to get the outline and do it in leather cut, that's one way to do it. Or you can just do it shaded. We can even play with textures at one point. You can bring back the lines. These lines are meant to help us understand the volume while we are building. Here we can see that our hole is still at the bottom. And if we want to do one last fillet here on this edge, we can do it. And little tip, if you want to print that, don't put a fillet on that specific one, because printers like to have flat surface going up. If you do want to have a little effect on that, use chamfer. This is a perfect spot to use chamfer. That's too much. Reduce that 2 millimeter, 1 millimeter even. It does bring a bit more detail to the product, But this way, what's good with chamfer is that the printer knows how to do sharp, going up sharply. It's this, once you're gonna start to print, the curve is going back in, so that's no problem. But try it on your buttons to print it flat, to print it with the fillet or with the chamfer. You're gonna see the difference in quality of roughness or smoothness of surface that you want to get. So if you want to print that glass, it's a cool glass to have, you can go here, click Save As, and in the Save As type, you're going to scroll down and choose STL, stereolithographic, STL. Go to Options and check that it's not like this. You see that here the deviation is called, what would that do? Deviation is equivalent to pixels. This would mean I don't have enough pixels. This polygon, when we talk about 3D printing, is how many polygons do I have to define my product. Here I don't have enough. Your print is gonna look with a lot of edges, and if you put, the moment you're somewhere in the middle, you can see that it's smooth again. Normally by default it should be around in the middle, but please do check. Okay, meaning that you click on Save As Type, you look for STL, you go to Options, confirm that it's in the middle. Okay, give it a name, usually put your first name. It helps in English what it is, so this way Tamar can figure out like what am I printing, because you can see that just here I have a lot of things that we did with students, from coins to buttons to things like that. Oh, I can show you some buttons we did with Madar, just to give you ideas of buttons. Don't have to be round, don't have to be flat, don't have to be straight. They can be any shape you want. So the moment you finish, just put it somewhere you know where to find it and save. That's it. Now you can see the idea of why I compare it with pixel resolution. Here we have many polygons, meaning we're gonna have the file has good quality, good data for the print to be successful. And that's it, we finished with this. So now let's look back fast at buttons that Madar did. She showed it to me yesterday, they look amazing. She printed with a slightly white pearl filament. It looked really good. So that's one of the ones she did. And this is smoother. Here you can see the little facets. So that's pretty smooth. And the other one was more rough. You can see the facets. These are other things that she created using this. I think next lesson I'm going to show you how we can take a graphic from Illustrator, bring it back to Solidworks to create this kind of sketches. Yeah, that was another button that she created. So that's one logic to make buttons with spots ready to stitch. That is not a go-through stitch like we did last time with all directly into the shape. I think that was that is enough for today. Make the exercise, build your cup, print your cup. I want to see them. Have fun.